Algebra I Honors, Lesson 5.3 to 5.5. Slope-intercept form and writing equations in both slope-intercept form and point-slope form. So, the book that we base this off puts us in three forms, but it's kind of nice to see them all. You've already seen standard form, and you've probably seen slope-intercept form before. Y equals mx plus b means that slope is m and the y-intercept is b. And then point-slope form, which is the least known and the most handy. So what are some advantages and disadvantages? Well, this one, if you have the slope and a point, it's very quick to write. It's also very quick to go backwards, and most people don't understand it's just slope. If I have m and I divide by x minus x1, I basically wrote m equals y minus y1 over x minus x1. It is really just slope, where we cross multiplied. And some will argue, well, I don't see a y2 or x2 in there. That's not the point. Slope-intercept is nice because you can pull the slope. Excuse me. Which is very handy information about an equation. You can also pull the y-intercept. So graphing is kind of a breeze. A lot of people like this because they can graph by intercepts. I'm not a big fan. There's a lot of details that go into that. It's kind of a hassle. Excuse me. So we've got these three forms. When do we use them? Almost always going to use point slope to start things. Probably then going to change it over into either standard or slope-intercept, depending what the teacher wants. In the world of algebra going forward, these are exclusively used. This does not pop up often. We've shown you a little bit about it earlier. So, how do we solve problems? Well, you find the slope first. So in this set of problems, write it in point, slope, slope-intercept, and standard form. That's a lot to do. Find slope first. Don't fall for the, oh, that must be zero trick. Negative 2 minus 2. You know what? I'm going to do a quick graph over here. 6, negative 2, negative 4, 2. Yeah, that looks like it's a slope of negative 2/5. Now notice the thing about slope-intercept, I can write it any way I want. I'll use the first one for no particular reason. That is point slope. Forgive the mind-blowing graphics. So that's done with point slope. Move the 2 over. A little tight on space here. So we get, I gotta multiply it out. Negative 2/5 x plus negative 8/5 plus 2, which is negative 2/5 x plus 2/5. So that's slope-intercept. Now, I would take this or this, multiply everything by 5. So I'll do it with the bottom one. 5y minus equals negative 2x plus 2. Move it over. 2x plus 5y equals 2. That's the only time I'm going to do standard form. It's not really necessary. I would pause this and try this on your own. See if you can do it. I'm going to put the slope up here just because of lack of space. Six over 3 is 2. If there's ever one with a 0, I'm going to work off of that one almost immediately. Y plus 4 equals 2 times x minus 0. You could leave it like that. That's technically point slope. You could also write it as y plus 4 equals 2x. That's also point slope. That's point slope. Y equals 2x minus 4 is slope-intercept. I lied. 2x minus y equals 4 is standard form. We like to keep the first one positive for standard form. So here, not using my labels, which I don't recommend you do, 4 minus minus 2, negative 3 minus minus 2 equals 6 over negative 1 equals negative 6. Point here, then negative 3, 4, point here. Yeah, that's a pretty steep negative slope. I like checking my work. I didn't check the middle one, I should have. Y, I'm going to use the second term this time. Minus 4 equals negative 6, x plus 3. Where'd the plus 3 come from? It's minus minus 3. That's point slope done. Notice there's two answers for point slope. Which one do you use? Whichever one you want. It doesn't matter. Move the 4 over and distribute. Y equals negative 6x minus 18 plus 4. Y equals negative 6x minus 14. Keep going. Again, I didn't do standard form on that last one. Let's look at what happens with each form when given vertical or horizontal lines. So this for me is all about graphing. Well, let's do the slope first. We say, hey, this is 5 minus 5 over negative 1 minus 3. It's 0 over negative 4, which is 0. So I do a quick graph. 3, 5, negative 1, 5. Horizontal line at the 0 slope. Yep, that's going to be y equals 5. Easy to remember because they're both 5. Y equals 5. Duh. Now that is point slope. That is slope-intercept form. If you really wanted to do point slope as y minus 5 equals 0 times x plus 1, I suppose you could. Once you move it all around, you get that. And that's also standard form. Over here, I'm going to take a wild guess. I think I'm going to get an m equals undefined, but let's check. I'm going to actually subtract the second one from the first. 5 minus 3, negative 2 plus 2. M equals undefined. Let me graph, see what's going on. Negative 2, 5, negative 2, 3. Horizontal line, which is a x equals line, and since it's negative 2 in both, x equals negative 2. That's point slope. That's standard form. That is actually as good as you're going to get for slope-intercept, even though it doesn't look like one. So now, graphing from each form. Graph the equations in slope-intercept form. Don't manipulate. Sure, why not? This is your b-intercept, meaning it's going to hit the, y-intercept, b value. It's going to hit this line here. And it's going to hit wherever it is, negative 1. The slope is up 2, 1, 2, 3 over. 1, 2, 1, 2, 3 over. I like to do it more than once. Makes my line a little better. That's it, we graphed. Negative 4x plus 5. This is your y-intercept. Go up 5. 1, 2, 3, 4, 5. This slope is negative 4 over 1. Down 4. 1, 2, 3, 4 over 1. Or up 4 over 1. And this is y equals 2x. Kind of freaks people out. There's an imaginary or invisible plus 0 at the end. So it hits here. This is 2 over 1. Up 2 over 1. Up 2 over 1. Done. This is tricky stuff. I'm doing it very quickly because it's kind of obvious to me, but yeah, just don't be shy about that. Now this one says don't manipulate the formula, and I'm not going to lie to you, I'm no good at that. I mean, I should be able to look at this and go, oh, I know what point it is. Well, when we did the point slope, these signs were flipped because it was y minus. So it's at negative 3, 1, 2, 3, positive 4, 1, 2, 3, 4. Prove that, put them in. Negative 3 plus 3 is 0, positive 4 minus 4 is 0. Yeah, it works. 0 equals 0. Then we can just do the slope trick from here. here is going to be at 3, -1. And it is down 2 over 5. Or up 2, left 5. Thought I wasn't going to hit my points on that one. Getting good at freehanding things. Here we have -5, 1, 2, 3, 4, 5, and -3, 1, 2, 3. Up 1 over 2, up 1 over 2. Oof, that was pretty bad, just when I bragged about myself. And there we have it. Point slope graphing. I still want to know what the y-intercept is, so I probably would have manipulated it, but yeah, we're done. And then the last but not least is doing it by intercepts. You can move it around, but the idea on this is that you can go, well, x is 0, then y is 2. And you have to just look at that and know. Plug in 0, this vanishes, divide both sides by 3. Okay, yeah, y is 2. 0, 2. Yeah, look at blue. Y equals 0. X is 3. X equals 0. Y equals -2.5. Right about there. Y equals 0. X equals 2. One more time. X equals 0. Y equals -1. Y equals 0. X equals -3. 0, -1. -3, 0. Off we go. Now, just so we're clear, I don't like standard form. I don't see myself ever using it, and I've done a lot of math. It's handy if we want to draw a graph and find out what's going on, but I still want to know the slope, and I still want to know the y-intercept and all that, so that's just me. In the middle of the 98 season, Mark McGwire seemed on track to break the record. He had 45 runs batted in. After 86 games, he had 87 runs batted in. That's a lot. Write a linear equation, estimate the number of runs batted in for any number of games that season. So we got to get our points first. And this is data that's just in the way. So 40 games, 45 RBIs. X1, Y1. 86 games, 87 RBIs. By the way, that's not on track, if I'm not mistaken about the record Lou Gehrig holds. But what do I know? Just reading the whole question again. So, slope. Something wrong there, that's for sure. 42 over 46. Doesn't seem right. Yeah, that's right. And let's write it in y equals mx plus b form after going through this process. I know that's not reduced. I'm going to handle that a little bit. Y minus 45 equals, yeah, I'll go with the decimal on that one. 0.913. Why 3 decimals? Why not? 36.5. I'd like to leave my slope in bigger decimals in this one. Add 45 to both sides. We get y equals 0.913x plus 81.5. No, that's not correct. Hit the wrong button on my calculator, which is why you have to be smart enough to recognize these things. Now, if we put in the number of games, I feel like I did all this wrong. No, games and runs batted in. 162, and blast this out. For 162, he will knock in 156 RBIs. Now, I don't know what the record is, but I don't believe he'll make it. Would help if they put that in here. Yeah, so we'd have to look it up. Anyway, ideal maximum heart rate for a 25-year-old exercising to burn fat is 117 beats per minute. For every 5 years older than 25, the ideal rate drops 3 beats per minute. So, y equals, it drops 3 beats per minute, -3 every 5 years. Plus 117. You might say, well, how the heck did he do that? We'll put in 0. What do we get? 117. That makes sense. With x being years after 25. And put in 5 years. It should go down 3 beats. We should get 114. Y equals -3 over 5 times 5 plus 117. Cancel, cancel. Hey, look at that. 114. Works very nicely. So there's our equation. Graph it. I'm going to go with 100. Now it's going to drop, so I got to be careful here. Let's go with 50, 60, and up from there. So 117, these will just go by ones, is about here, and then it's down 3, 1, 2, 3, and over 5. Well, I can't do that because I don't have the same scales going. So this will have to go by tens. 10, 20, because these go by tens. 30. So now I can do it. 1, 2, 3, 1, 2, 3, 4, 5. Remember, these are years after you're 25. So, after 25 is x equals 30. So go out here to 30, and we go up, and it looks like it's about 100 beats per minute. That's a very rough number. It's not exact at all. So you got a lot to do. I mean, point slope, slope-intercept, standard form. There's a lot cooking here. So get on it. Good luck, and as always, happy mathing.